Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving count the number of ideal arrays. So the problem states that we are given two integers n and max value, and we want to return the number of ideal arrays of length n that we can make. So to make an ideal array of length n, all the values in the array needs to be from 1 to max value. And for every value that has a previous value, the previous value needs to be divisible by that value. So if we look at this example, there's 10 ideal arrays that we can make. As you see, all these arrays here are divisible by their previous value, and they are all between 1 and 5, which is the max value. And in this example, we can form 11 ideal arrays where all the values are between 1 and 3, and every value is divisible by its previous value. So now that we have seen some examples, let's get to how we can solve this problem. I think for this problem, I will mostly explain as I go through an example since there are quite a few steps, but to give some intuition, these are the obvious ones, where if it's the max value, just fill every number from 1 to max value with that number. So we will have 3 already, and throughout the problem, we will use this combinations formula, which is n factorial divided by n minus r factorial times r factorial. So here we are basically figuring out how many arrays we can make with one number change, and it will be 4. So for the first parameter, we will plug in n minus 1, and the second parameter is how many change. So over here, when n is 5, we can plug in 5 minus 1 here, which is 4. And then if we want 2 changes, then we realize that we can make 6 combinations. So initially, we will have all the arrays with 0 changes. I'll put them down here, but just know that when we actually code this out, this will not be there. This is just for you guys to visualize. So initially, we will have all the arrays with no changes, and that will be the max value. So initialize result to 8. And this frequency hash map will represent the number of instances where it can reach that number with k changes. Right now, k is equal to 0. And now we're going to find out the number of values that can be reached with one change, where k is equal to 1. So what we will do is we will use the combination formula times the frequency as certain numbers, and then we will add that to the result. And then to update the hash map, we will do the number we multiply by times x as the key, and for the values, we will add by the frequency of x. So let's go over this example real quick. So first we will start at the number 1, and we can multiply by 2. So we will add 2 here because 2 times 1. Then we can multiply by 3. And as we can see, there are 2 ways. So update result. Then we can multiply by 4. Update result again. Update the hash map. 5, 6, 7, 8. And as you can see now, we currently have 22 arrays. And we have multiplied up to 8. We don't need to multiply by 9 because that will exceed the max value. And now we can check how many we can reach starting with 2. So we'll update here because there's 2 ways to reach 4. And so we need to update the frequency at 4. And then now we can multiply by 2 and reach 6. 2 times 3 is 6. So we update the result. And then 2 times 4 is 8. So we update the result again. And we don't need to do 2 times 5 because that will exceed max value. So let's check how many we can reach with 3. So 3 times 2 is 6. So we can update the result again to 30 and increase by 2 each time because 2 times 1 is 6. And we don't need to do 3 times 3 because that will equal to 9. So let's see what we can do with 4. 4 times 2 is 8 and 2 times 1 is 2. And as you can see, we can add 2 arrays here, and now the result is 32. And we don't need to do x is equal to 5, 6, 7, or 8 because if we multiply these numbers by 2, it will exceed max value. So we know that it cannot reach any numbers. So now we will set frequency to this new temp array, and then we will now search for the combinations that we can make with 2 changes. So first, we start at 2. And as we can see, 2 changes here. So we update result to 33. And 1 times 1 is 2. And 2 times 3 is equal to 6. So we can reach 6 in one way. So we update temp here again. And then we can also reach 8 one way. Update result and temp. And now let's see what we can reach when x is equal to 3. 3 times 2 is 6. And as we can see, there's one way to reach 6. And now let's see what we can reach with 4. Now be careful. 4 is equal to 2. So we will do 1 times 2 and then update the result by 2. And then we will also add 2 to 8. So as you can see, there's 2 ways to reach 8. And then we will skip 5, 6, and 7, 8 because if it multiplies a number by 2 or higher, it will exceed max value. And we have looked through 2 changes, and that's the most changes we can make when n is equal to 3. So we can return 38 as our result now. And the time complexity would be O of n log m, where n is the value of n right here because we need to look through how many changes there are. And m is the max value because looping through the frequency may take log m time. And the space complexity would be O of m because the frequency hash map can take up to m space. So now let's get to the coding part. So first we'll initialize result to max value, and we'll initialize the frequency frequency hash map. So it will be x colon 1 for x in range 1 to max value plus 1. And now we will loop through k, so for the number of changes for k in range 1 to n. And we'll initialize the hash map to empty, so just counter. And then now we look through each number in frequency. So for m in range 2 to max value x plus 1, so that's what we multiply by. So we'll update result with combination times the frequency of x. And then we'll update the temp counter with m times x as the key, and we will add by the frequency of x to the value. And then after the for loop, we will update the frequency counter, and then we need to modulo it in case the number is too big. And then finally, we can return result. See if it works. Okay, perfect. Hope this is helpful. Thank you for watching. If you have any other questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.